And I'm Dan.
And today we're going to be learning about unit conversion. It's really important to pay attention to your units so that you know you're using the right quantity of a substance, as well as so that when your teachers are marking your tests, they know what you're doing. In Canada and the majority of the world, we use the metric system for measurement. So this includes grams for measuring mass, liters for measuring volumes, and kilometers and meters for measuring distance. We also use units based on these larger family of units, such as kilometer, which is 1,000 meters, and milliliter, which is 1/1000th of a meter. These are prefixes you can add to the fronts of units to change the scale of quantity that they are referring to. The three main ones you'll come across in first year are kilo, milli, and micro. Kilo means 1,000 of that unit, so a kilogram is 1,000 grams. Milli is 1/1000th of that unit, so a milliliter is 1/1000th of a liter. And then micro is 1/1,000,000th of that unit, so a microliter is 1/1,000,000th of a liter.
Now, let's work through an example of converting between different units in the SI system. So, let's start with the example of we have 0.012 grams. So, we have our 0.012 grams, and we know that 1 gram is equal to 1,000 milligrams. This is fairly intuitive, but to make this a conversion factor or a unit conversion factor, we're going to want to write that as a fraction so that we can cancel our units out. So, writing this in a fraction, you can say that per 1 gram, you have 1,000 milligrams. So something like this. So for 1,000 milligrams, you have 1 gram. And you can write that in the inverse. You can say that 1 gram for every gram you have 1,000 milligrams. So now if we were to write 0.012 grams into milligrams, we would use this conversion factor to get it there. So we would say 0.012 grams multiplied by our conversion factor into milligrams times 1,000 milligrams here over 1 gram is equal to, I'll erase that here, 0.012 times 1,000, move your decimal over, is 12 milligrams. So, now we've worked from 0.012 grams to 12 milligrams, and the best way to check that your answer is correct in any calculation is to cancel your units out top and bottom. So you see we have grams on top, grams on the bottom. You can just X those out, leaving just milligrams, which is the answer of your question. Canceling units like this is really nice to see where you are, and your teachers will be very happy to see that you canceled your units and made sure that your answer is right. Now, the same principle that we just worked through from grams to milligrams works in reverse. So let's say you have a 10,560 milligram sample of fish. So you have 10,560 milligrams, but that's kind of messy. That's a really big number. So let's go back to grams. We're going to use the same conversion factor we used. You know that for every 1 gram, there are 1,000 milligrams. So you're going to write your 1,000 milligrams down here. You divide this by your 1,000, giving 10.56 grams. And as I showed you the last time, to make sure that that is right, you simply run through and see that your milligrams cancel top and bottom, leaving just grams, so you know that the conversion worked. Conversion factors also exist across different unit families when the conversion factor is a constant. A good example of this is density. So the density of water is 1 gram per mil. So for every milliliter of volume of water, the mass will be 1 gram, and vice versa. So let's say we have 5 mils of water. If you want to know the weight of that, you simply use your conversion factor again. You know that for every 1 gram of water, that's going to equate to 1 milliliter of volume. So that you know that once you've done this out, you have 5 mils times 1 over 1 is simply 5. So you'll have 5 grams of water. Again, canceling your units always helps. So you know that the conversion factor worked and you went from one family of units to the next. Note, for things like density, the conversion factor of 1 gram for 1 mil of water only ever works for water. Naturally, something like lead, for 1 milliliter of lead, it's probably going to be much heavier in terms of mass. So always make sure you're using the right conversion factor and make sure it's the right constant.
Molar mass is another example of unit conversion factor that you'll become very familiar with using this year. The molar mass of sodium chloride, also known as table salt, is 58.44 grams per mole. If, for example, we needed to add 0.15 moles of sodium chloride to our reaction, we can convert by the molar mass to get to grams. So that's 58.44 grams per 1 mole. You can see here as well that the units cancel out. So we have moles on the top and moles on the bottom. So if we get rid of both of those, we're only left with grams. And then if we do the math calculation out, we get equals 8.76 grams of sodium chloride. And that's how much you would have to add. Okay, we can also go the other way by flipping the conversion factor. So let's say we have 12 grams of sodium chloride. To figure out how many moles we have, we can use the conversion factor in reverse. So we have 1 mole per 58.44 grams. So we can see again here, our units will cancel out with grams on the top and grams on the bottom. They cancel, and you're left with the units of moles. When we do it with the numerical calculations, we're left with 0.205 moles of sodium chloride. So similarly to density, molar mass is specific to the substance. This is the molar mass of sodium chloride. You could not use it for nitric acid, for example, or any other compound, only for the one specific to what you're doing. We hope this video has been helpful for your learning. If you still need more instruction, there are many other videos available online, as well as tutors available through the Chem and Biochem Society. Thanks for watching!